Hello friends. If you haven't done so already, you'll need to download the Godot game engine from godotengine.org. The engine is free, but you can donate to support the project if you want to. There is no installation process, you can just extract the zipped file and open it. Be sure to relocate the executable to a better location. The initial launch window is a list of your current projects, but if you don't have any projects yet, you'll be prompted to explore demo projects. We can ignore this and just create our own new project either by clicking on this button in the project list or the Create button at the top of the window. Here we can give our project a name, which would typically be the name of your game. I'll just put Intro to Programming. The project needs to be stored on our computer's hard drive, and we'll create a new folder with the same name of the project. By default, it wants to store everything in the Documents folder, but it would be better to create a new subfolder for Godot projects. The renderer changes how certain 2D and 3D objects are rendered, but we won't be drawing anything, so we can ignore these options. The renderer can also be changed later. And version control compatibility with GitHub is included by default if you want to use it to back up your project or share it with others. When you're ready to start, click Create and Edit. The Godot editor window will open our newly created empty project. The editor is divided into 5 main docs. A preview of our game is in the center. The lower left dock contains a file browser showing the contents of the project folder we just created. It currently only contains the Godot icon. The upper left dock contains the scene tree, a list of everything that is in our current scene, which is currently empty, so it wants us to create a root for the scene tree. We won't be drawing anything, so we don't need to specify if this scene is 2D or 3D or a user interface, so we can just select Other Node. There are a lot of different nodes we can create, but we are only interested in learning how to write scripts, so we will just use a default node. We can rename our new node by clicking on it after it has been selected, or right-clicking to open its context menu and selecting Rename. Let's name this node Lesson 1. Selecting any node in the scene tree will reveal its properties in the inspector, which is docked to the right side of the window. We can see the name of the node that is selected and its properties organized into expandable categories, but none of these properties are applicable to what we're doing. Before we do anything else, we should save our new scene, either by selecting Save Scene from the Scene menu or using the shortcut Ctrl+S or Command+S. This opens a dialog box where we can specify a name for our scene with the tscn extension, and a destination folder. Let's create a new folder for Lesson 1, then save the scene in this folder. We can now see in the File System tab that our new folder has been created for Lesson 1, and it contains the Lesson 1 scene, which is marked with the clapperboard icon. Next, we'll attach a script to the root node of our scene, either by selecting the root node and clicking the Attach Script button, or by right-clicking on it and selecting Attach Script. The language is GDScript, which is the programming language we are going to be learning. Every script will inherit from the node type it is attached to by default. Since the root node is a default node type, our script inherits from node. We are not using a template nor a built-in script, and we can specify where this script will be stored within the project. Let's put this in the same folder, Lesson 1. When naming scripts, it is important to not be arbitrary, but instead describe the type of object or behavior we are creating through the script. So let's name this Hello. Scripts have the file extension .gd. Then click on Create to create the script. This will switch our preview to Script View, displaying our newly created Hello script. We can also see our script in the File System tab, indicated with a cog icon, and the Lesson 1 root node has the script icon to show us that it has a script attached to it, which when we hover over, will tell us the name of the script. Clicking on this icon also opens the script if it isn't open already. Our script only has one line, which describes its inheritance from the basic node type using the keyword extends. This just means that our script can do everything a node can do, plus anything we write here. It also allows us to override the behaviors of the node that already exist with new behaviors of our own. For example, nodes have a function named ready, but it doesn't do anything. So if we want our script to override this behavior of doing nothing, we can declare our own function of the same name using the keyword func. Func is then followed by the name of the function, typically written in lower snake case, which means all lowercase letters separating words with underscores. Many of the functions defined by nodes are preceded with an underscore, and the name must be an exact match to override the behavior. The name of the function must be followed by parentheses and a colon. We'll go over why later. Pressing enter after this line, the next line is automatically indented by one level. This is how GDScript knows which lines are contained within the function and where it ends. The line is highlighted in red because functions are not allowed to be empty. So it is a good idea to write the word pass to give new functions a body that does nothing. Now that the error is gone, we can see this blue arrow icon appear in front of the function declaration, which is the override symbol, indicating that this script is now overriding the ready behavior of our node. Instead of doing nothing, we want our node to say hello, which we can do with a print statement, replacing the line that previously said pass. The print statement looks similar to a function declaration with a name followed by parentheses because it is calling a built-in function. This function requires an argument, which is what goes inside the parentheses. And this argument is what will be printed. Using quotation marks, we can write anything we want, and it will be printed out by our script when the node is ready. Since the script is named hello, the behavior we want to create is for the node to say hello. With our script ready, we can run our game using the Run Current Scene button in the upper right, or using the shortcut F6. This will display an empty window, since our game doesn't draw anything, but it also opens up the fifth dock, displaying the output panel. And in our output, we can see our node has printed the words "Hello World" when it was ready. We can end the simulation by closing the window, clicking on the stop button, or using the shortcut F8. We can change the text that is printed to say anything we want and run it again to see that our node can print out anything we tell it to. We now know how to attach scripts to nodes and run them. In the next lesson, we'll learn about constants and variables. I'll see you in the next lesson.